Hello everyone, my name is Anu Rao. I am product manager in data center group at Intel Corp. And I'm excited to bring SPDK 4 times in a row in Tech Field Day. So it's exciting. I know, you love SPDK. I can see so much excitement here. Nice to see that, 4 times in a row. We have new features with SPDK I'm excited to share. And I'm hoping I can unleash first time in Tech Field Day where we are able to unleash Jim Harris, our principal architect of SPDK, later today. So save all your hard technical questions for him. Okay, so SPDK, okay, this is the most important slide.
Do we have to read all of it?
Yes, you need to memorize it too. I just read.
Pop quiz.
So,
gotta love the lawyers.
Yes. So a quick introduction to SPDK, and apologize. This is a basic slide. Everybody knows how storage has evolved. I need this in order to lead to my next slide, so bear with me. I won't spend more than 5 seconds on this. So storage has evolved starting with hard disk drives, which takes milliseconds for data to come back, to SAS SATA drives where you have an external controller, to direct attach PCIe drives, which changed the way, brought storage close to CPU, changed the way storage is done, to, you just heard Andre's 3D XPoint technology. This is the first time we have had where, I can use SPDK after a 3D XPoint technology where, this makes so much sense, especially with the fast NVMe drives. Having optimization software like SPDK is so critical. So, you might have seen this 100 million times. I'm still going to show this because this is the key important factor why you need optimization software like SPDK. Hard disk drives, the drive latency is enormous. It's milliseconds. It's, most of the software is designed for these kind of drives wherein you send the I/O request, go do something else because it takes a long time to be polling. So polling is not cool at all with hard disk drives, takes forever. And then when the data comes back, the CPU is interrupted, then CPU goes back and gets the data. Software involved in the context switches needed to go from the application space to kernel space in order to access the driver to go access the device takes a long time. It doesn't matter because your drive takes even more longer time to bring the data to you, so the processor can go do a lot of other cool things while it's waiting for the data. So interrupts are something that's been implemented for a long time because that made so much sense with hard disk drives. As we move towards SAS SATA, things change. Still the software latency is not that significant, but if you come towards 3D XPoint, now it's 30%. And this is the best case scenario where we're just showing the minimum software with the driver latency. But if you use the whole storage stack, it's going to be even more significant. And it's eating up your, if you're investing money to buy fast NVMe SSDs as the technology of media keeps changing and it becomes even faster, your software is eating up a lot of those performance, and that's becomes more and more significant. So with that in mind, SPDK is something that can help with eliminating this software overhead. Because now software need to get the act up together because the hardware is faster. And as it gets more faster, software will become a problem. So what is Storage Performance Development Kit? It's a user space, so this is the key. You don't have to go into kernel space to access these NVMe devices. It's a user space, lockless, and logs, context switches, and interrupts is very expensive. It can actually be up to 20 microseconds to get all those things processed, whereas your data from your fast NVMe, even if you take the 3D NAND, it'll be like the 20 microseconds matter because your data comes back less than 100 microseconds, which becomes a problem. So having a user space, lockless pole mode driver definitely helps. And because of which you can actually get millions of IOPS per core performance. And of course, I have the performance data to share with you to show that. And the other key thing is optimized for latest generation CPUs and SSDs. What that means is, as you move to newer generation of CPUs, newer generations of SSD, doesn't have to be Intel SSD, it can be any SSDs. You don't have to go change the core SPDK software. It works. It scales with your hardware. And it's not only helpful with your local attached SSDs, it also helps optimize even more so with NVMe over Fabric, NVMe over TCP, which is the next cool thing that's coming in the industry. And of course, with virtualization systems. So in fact, we have the next session, we'll go deep dive into virtualized systems using SPDK as well as NVMe over Fabric using SPDK. And the good news, it's open source and BSD license, which is the most free license there is. So anyone can use it. It's available through spdk.io webpage. And of course, we do have a Twitter account now, so please follow SPDK project to get latest news and updates on events on SPDK.
So the SPDK is not really Optane specific.
No, it works with any SSDs. It makes sense with faster NVMe SSDs because, as I said,
Even any NVMe SSD.
Any NVMe SSDs, yes. But we are from Intel, so we test with mostly Intel SSDs, but that doesn't mean it doesn't work with any other SSDs. It should. Any other questions? Okay, moving on. So this is a snapshot. I don't want to spend too much time showing you performance. This is a snapshot of what SPDK can bring, not only with local NVMe SSD, but also over NVMe over Fabric. And it shows how much software latency that it reduces going from kernel to SPDK. Is actually over 12x there, the last chart over there, the left-hand side. With media, it actually reduces, you get way more performance for way, lesser, it actually saturates up to 8 SSDs. So you can add more SSDs and still get the maximum out of that, one core performance. Whereas with kernel, it saturates with just one SSD. And then you don't see the performance going up as you add more SSDs because the CPU is saturated.
That's cool.
With Fabric, you actually can get pretty close. Even the kernel as well as the SPDK performance-wise is pretty close. But the number of cores matter here. You get that much performance with SPDK with just 4 cores versus 28 cores. We are not telling you to buy less cores. You can use those cores to do a lot more storage functions. You can do more encryption. You can do more compression instead of spending all of those cores to just get the data to your system. So that's where it benefits. It benefits with performance. It reduces latency, and it actually scales virtual machines too. I don't have that here, the chart, but actually you can scale 2x more, actually 3x more virtual machines compared to kernel, and awesome CPU utilization. This is what we have tested in our labs. Now, what does the industry say? Who else is testing SPDK? So I have few industry examples where they have used SPDK and published papers, where they have tested SPDK and published papers. And we also recently had company actually did a POC with SPDK with NVMe over TCP and presented at Flash Memory Summit.
So the IMDT is only available in Linux, and the SPDK is only available in BSD, Unix?
It's available Linux and FreeBSD.
Oh, okay.
Yeah, it works in both. Rest of the OSs, it's not open source, so we can't go and integrate it. But if they are willing to adopt SPDK, it's there, free. So Microsoft can use it, VMware can use it, it's there.
It's not like Microsoft has any NIH or anything.
Well, we actually found a white paper from Microsoft Research. I, in fact, had that as a testimonial. I took it out because it was just a white paper where they have done some testing. And they did show over 1/3 reduction in latency using SPDK. But I don't think they did it with Windows Server. It was mostly on Linux.
Yeah.
So, So you have seen this before, so I may not spend too much time on this. This is from Ali. So they used vhost, the virtualized systems, and used SPDK with that. So they were able to see over 300% improvement. And every time I show this chart, we always get questioned, what are those 1, 2, 4, 8, 16? It's the queue depth. It's not the number of SSDs, it's the queue depth. And they saw a very good improvement using SPDK. And I know that Yes. We have our principal architect in the room, so I'm relieved I don't have to do his section. So Ali showed over 300% improvement in performance.
Wow.
We found this from IBM, where like the slide I showed earlier that we tested is kind of, this one says similar thing. They tested this with, they did, like the left-hand side is the kernel, the right-hand side is the user space, whereas they've used one NVMe SSDs, on the other side is 12 NVMe SSDs. This kind of collaborates what I said earlier, that, the kernel saturates your CPU with just one NVMe SSD, whereas with, running on SPDK, you can actually go a lot more NVMe SSDs, and it still gives you performance. So this shows the CPU utilization, and IBM also saw this. So they actually get over 3.9 million IOPS using SPDK. And it's saturated at 12 Intel. Well, this is not Optane. This was done much before. So they used I think, P3600 flash device to test this. And this one, they actually used, this is to show the IOPS, the throughput, with NVMe SSDs. And they actually saw over 9x improvement using SPDK versus kernel. And they used SATA to compare, saying as you move towards NVMe, the performance, the software optimization makes more sense, versus you see the performance, like we get this question, will SPDK work with hard disk drives? Yes, of course, it works with hard disk drives. But if the time taken for data to come back in milliseconds, optimizing few microseconds, you won't see it. So it works. It's not going to make it any worse, but you won't see the performance benefit with hard disk drive. But NVMe drives, yes, you definitely see it. And it is not 10%, 20% is 9x. So it does help quite a bit. And that's the link to the paper if you want to get more information on their work. And this one they compared with Optane versus NVMe flash. And then you can see that with Optane, you can get 2.x lower latency compared to NVMe flash, because Optane is much faster. And optimizing software there makes so much sense. Any questions so far? Okay. So this one was interesting. We didn't know that they had announced SPDK when they actually did their earnings report. So this was Broadcom, NetApp, and SOSE when they announced the availability of their latest end-to-end NVMe or fiber channel solution. And they were highlighting that it delivers 50% more IOPS and 30% lower latency. And guess what? They were using SPDK in their solution. So this was really interesting to see that they were seeing good performance with SPDK. And I have the link there if you want to get more information on that announcement. Last but not least, we have, this is the one I mentioned. So this year, this followed actually Rob Crook's keynote at FMS. So this is from Solar Fair. I think I was the only one sitting there. Most of them from my teammates had left. And then I saw this picture with SPDK in there. I was like excited. So I took a couple of pictures. This is one of them that I took. So actually, they, I think, are one of the few who have used SPDK in their NVMe over TCP solution. So this is something that we saw at Flash Memory Summit, where there was a lot of interest in NVMe over TCP, and this was really exciting for us to see that, that our company has used SPDK to provide the NVMe over TCP solution. And SPDK, I think Jim will talk about it, maybe flash it a little later, that we have plans to integrate user space TCP, which is the VPP, with SPDK to make that available to everybody. So this was really exciting. Okay, before I move on to the architecture part, which I'm sure you're all waiting for, I want to give a quick overview of SPDK community, how it has grown in the past 1 year. And it has grown tremendously. So we have spdk.io webpage where you have a lot of resources available for developers. We have a mailing list that please subscribe to where you get, if you have a question on SPDK, you get within few minutes response from our community members versus sending it to Intel, to us, because they are also active and they all might have seen the problems you're seeing already and solved it. So please subscribe to email list, mailing list for SPDK, because if you have any technical questions, the response, I myself am a subscriber, I see response coming back within a minute or two. And it's not just from Intel.
We're all one big happy community.
Yes, we are all.
There in the middle.
Yes.
Sort of representative of.
Or so you'd like us to believe.
Well, we are. You can come by sometime to our developer meeting. We do have a developer meeting and then a developer meetup coming up, where we do have that, dancing together.
That's right.
Yep. So
I really don't want to see a whole bunch of engineers dancing.
Especially now.
So we also recently started a weekly developer meeting. It's friendly to PRC time as well as US time. So we have it twice a week, and anybody is welcome to join. And if you have any questions with regards to, what are the features that is interesting to support in future for SPDK, please come there, because majority of the ones who are attending are the ones who are contributing, to SPDK and who are very active there. So please come and talk to us and contribute and participate. Even if you want to just listen to the conversation, you're welcome to come and participate. And of course, we have GitHub where we do code reviews, and all our maintainers are very active in continuous, looking at the code and submitting patches and approving patches. So that's one way to go submit patches. The other features we have, there is a Trello where you can actually go see SPDK roadmap. It's available for everybody to go see. In fact, some of our slides, decks that we present to customers has SPDK roadmap from Trello. So it's open, everything is open source, so you can go take a look at the web page. And the other key thing I wanted to mention was we recently had a second SPDK meetup in US in May, and we had a lot of the presentations recorded. So we have posted all the videos on the spdk.io webpage. So if you want any deep dive on any of the features or what other companies are doing, like Nutanix presented their solutions. We had presentations from Cisco and other companies, so feel free to go check it all out. And this is something I wanted to flash, because SPDK has grown tremendously in the last 1 year. We have had over 70 unique companies participating in our community. It's becoming a big, happy community while dancing. We added 20 new features, and we have had, since we captured this after the SPDK meetup, which was in May, and we have seen over 100% increase in our web page, and to our community participation. So my ask to all of you and those who are watching online, please participate in the SPDK community and contribute, because that's the way we grow this software, and that's the way we can make the best use of this software, so it's useful for everybody. So anyone can avail it. Okay, now quick down to the little more technical, although
quick question.
Jim, yeah.
And you may not have visibility to this, so maybe that's the wrong person, but is there any benefit to contrasting adoption of this to how it went for the networking side with DPDK?
Yeah, in fact, we are looking to have SPDK move to the foundation similar to DPDK. But yeah, definitely, how DPDK grew, SPDK open sourced much later than DPDK, and we are kind of going along the same path, following similar.
I would kind of say we're probably about, if you look at when SPDK started and when DPDK, where it was at, I'd say we're probably about 4 to 5 years kind of behind, where they're at.
Okay.
So I think, we're not part of a foundation yet, like Anu mentioned. We're definitely building the community as if it's under a foundation, right? Mm-hmm. So we have committers that are outside of Intel.
Okay.
We try, very hard to make it to where it's, we're welcoming. We've accepted patches to enable ARM and Power. We accept patches to enable SSDs that are not Intel SSDs. Sometimes there's some quirks, et cetera. And I think especially over the last year, we've been seeing a lot of contributions from a lot of other companies. We've had Hitachi has core maintainer Shuhei Matsumoto, companies like Broadcom, Western Digital, Chelsea-O, Mellanox have all been active, pushing patches, pushing features. So we're still not at the level of DPDK, but I think we're moving in that direction.
But I mean, it makes sense because you definitely have the same kind of wow factor, right? I mean, the increases you guys are showing, I mean, are potentially really, really impressive. But the really cool thing on the networking side was when you started to see other vendors starting to push numbers that were beyond what anyone was predicting. I mean, you really started to see some competition pop up, and so it'd be nice to see something like that evolve on this side,
That's our goal. Yep. Okay, quick look into the architecture. Although Jim will go details on some of the features. So SPDK has a storage protocol part, and then we have the services, which kind of abstracts the protocol or the application from different protocols that it uses and which devices it's mapped to. So this does the translation from different protocols to access the device. And then you have the drivers. So on the protocol side, we support NVMe or Fabric protocol. We have the RDMA support, and the TCP is coming up. As I said, there's one company which has already used it. We are looking to integrate VPP, which is a user space TCP, into SPDK. And that's coming up sometime end of this year. And we, of course, support iSCSI Target, which we have been for a long, long time. And then vHost, which was like a little over a year ago we started supporting, which helps actually use SPDK in your virtual systems. On the driver side, we have NVMe or Fabric Initiator, and then you have your PCIe driver for local device driver for local drive access. And then you have the quick data technology, which is the DMA. So you have a user space driver to access that. So the block device abstraction is the layer that actually provides a bunch of storage services. So the third party, in fact, using that, you can actually integrate storage services like your compression, encryption. And in fact, I think we are planning to do the DPDK encryption enable, the APIs enable to
that's awesome.
Add the encryption capability through SPDK. It's coming up end of this year. So you can use the third party APIs to integrate storage services. And then logical volumes is something Jim will go through. So basically what this is think of it as a not 100% SRIOV, but SRIOV-like feature in software, in the absence of SRIOV in hardware. So it's basically like your LVOL from Linux. So you can assign different partition of SSD to virtual machines on the fly. Is what this provides. And Jim will go in detail if you have any questions on that. Yeah. And GPD, we have had that for some time now. It's again the partition table where you have to do it at boot time. And QoS is an evolving thing. We add optimization as we go, but then we have few optimizations where you're not letting a VM hog onto all the IOPS. So there is QoS feature available, so you can limit each VM how much IOPS it can consume. It's done at the beta level. Sorry?
Throttles.
Yeah.
Okay.
Yeah. So that feature is there.
Proper QoS is a lot more than throttles, but
yes.
Throttles are better than nothing.
Yeah, and so I think that's the important part is that, as Anu said, this is evolving.
Yeah.
So right now we have some basic throttling, and then there's other types of QoS where you want to provide a minimum guarantee. We don't have that yet, so I think this is going to evolve over time.
That's why it's up there.
Even and depending on the use case, even with throttles, if you're a solution provider and you sold somebody 100 IOPS, you don't want to give them 200 IOPS because that's another tier that you want them to pay for.
Right.
But if you're an enterprise, then you want to say limit this application to 100 IOPS when there is any contention, but give him all he wants. There's resources.
Yep.
So that the QoS starts getting complicated really quickly.
Yep.
And I think that maybe we should make that a little bit of, mid-orange and green just to show that it's evolving and it keeps changing. We add new features as we go. Yep. Totally not. And then these are the different devices that we support. So it basically what block device abstraction layer does is it converts different protocols into, you can access any of these devices. application need not worry about changing from iSCSI protocol over to or accessing NVMe devices with NVMe protocol abstraction layer. You can access NVMe device or iSCSI device or even PMEM device. You can even access your persistent memory device through SPDK.
And you can do foolish things like layer SCSI on top of NVMe.
I'm sorry, I didn't catch.
Sorry, what?
You can do foolish things like layer SCSI on top of NVMe.
Bite your tongue.
You can.
Want to. Yep.
Can we get that stricken from the record? I don't want anything to.
I did say it was foolish.
Okay, and then we have the blob FS and blob store. I think Jonathan went through this last year. I remember that. But basically what this is a very basic file system. In fact, I think we designed that for RocksDB support, which is the key value store database. So this provides the optimization for RocksDB. That's how it's evolved. But then we also use that for logical volumes and other things. So it's kind of, again, evolving to support different features as we go. And we have integrated a couple of, QEMU is something that we have integrated to provide you that virtualized system support with SPDK. So we have integrated SPDK with the QEMU hypervisor. We have integrated Ceph with SPDK, RocksDB. That's why we created the blob FS and blob store to provide the optimization for RocksDB. And what's in work is Cinder integration as well as the VPP, the user space TCP IP integration into SPDK. So those two are coming soon.
Remind me what VPP stands for?
It's a user space TCP. That's Cisco FD.io. They started it. Yep. Okay, any questions on the architecture before I move on? We have the architect here, so.
And I'm going to go into some more details
Yes,
on this in the next.
Especially the QEMU and maybe NVMe over Fabric a little. So, yes. So quickly going over the use cases because I want to give Jim lead after this. So I want to just highlight some of the use cases that you can use with SPDK. So RocksDB, something I mentioned earlier. So we have integrated RocksDB with SPDK. So it pretty much uses the BDEV. That's where you have the optimization that's done and access the NVMe drives. So you get good latency improvement with this. And the other one is something we are working on is that storage services I mentioned earlier, where you can actually do compression and encryption through SPDK. And this is something we are working on. And one of the cool things here is you can actually use features like ISAL, which is software storage services if you want to use CPU cycles, or if you want to offload it, then you can actually use QAT. So you can access either the software or the hardware, storage services using the abstraction layer, which abstracts it away from the application. So this is something we are excited to able to provide it.